Section 3.2 is on graphing quadratic functions. In part A, we're going to graph quadratic functions that are in vertex form. Alright, so the first graph is really just the graph of x squared. So we've already probably done this graph. We're just going to go ahead and fill in these values. So negative 5 squared is 25, negative 4 squared is 16, negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1. Then I'm going to have 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So we're just going to plot each of these ordered pairs. So starting with negative 5, 25, negative 4, 16, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, and the same thing on the other side. So 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. Okay, so I've got my graph of the quadratic x squared. All right, there we go. Okay. Now, in the next example, we're looking at functions of the form a times x squared. So we've got a coefficient a multiplied by the x squared function. I want to see how it affects the graph. So the graphs of x squared, 2x squared, and 4x squared are drawn. I want to know which one is which. So what I want to see first is which one is x squared. I can see the ordered pairs here for x squared. I just want to compare them really quickly and find. So like 1, 1, 1, 2, 4, 3, 9. This one has to be the graph of x squared, right? You can see over here 5, 25. This is the only one that matches the ordered pairs of the graph I just drew. So the outer one, the lightest gray one, has to be f of x equals x squared. The other two are supposed to be twice x squared and 4 times x squared. So if we take one of those values, like 3, 9, and double it, it would put me at 3, 18. So this one has to be, the middle one has to be g of x equals double, or 2 times x squared, and then the innermost one has to be 4 times it. So the innermost one has to be h of x equals 4 times x squared. One of your values, such as 2, 4, multiplied by 4, all of a sudden 4 times 4 became 16, so you're 216. Okay? So, I've got each of these labeled, and what I can conclude is the larger the size of A, the word I would use is narrower. My innermost graph is narrower because it had a large value of 4. So the larger the value, the narrower the parabola. The parabola, of course, is the word for the graph of any quadratic. So these are all parabolas. The larger the value of A, I can see from this graph right here, the narrower it makes the parabola. Right. What if the value that we're using, instead of being a large number like 2 or 4, is a small number like 1/2 or 1/5? I'm going to label each of these. So I'm looking first for the one that is the same as my standard graph. I'm looking for the one that has ordered pairs, such as 2, 4, 3, 9. So this one right here, the light gray one again, is f of x equals x squared. Now, if you take each of those x values and halve them, that would be 1/2 x squared. So instead of 2, 4, it would be 2, 2. So this one has to be half of x squared. So this would be g, right? G of x equals half of x squared. And 1/5, if you divide them by 5, multiply them by 1/5, then the one I would probably notice would be 5. 25 became 5, 5 because you divided 25 by 5. This one would be h of x equals 1/5 x squared. And again, what we're trying to figure out is what is the effect of that fraction, and compared to the base graph, the smaller the fraction, the smaller the size of A, the wider the parabola. 1/5 being a smaller fraction than 1/2, so that 1/5 got even wider than 1/2 and even wider than x squared. Okay. Alright, so another set of coefficients. What if instead of multiplying it by any number that was positive, what if I multiplied it by a number that is negative? So we'll look at the effects of negative 1/2 and negative 2 in the graph. First of all, I want to find negative x. So this is the ordered pair that would have the same y values, but they would be negative. So for example, you would have 2 negative 4 instead of 2 positive 4. And you'd have 3 negative 9 instead of 3 9. So f has to be this middle graph. If you take half of those values, instead of 2 -4, it would be 2, -2. So this one has to be g. So g of x has to be -1/2 x squared, and then multiplying them by -2 is going to increase them and make them negative. So it would be like 2, -8. So that sounds good. So this middle one, or this one in the center here, this light gray one, has to be h. So h of x equals, -2 x squared. Okay. So once again, that coefficient 2 made the graph narrow, and the coefficient 1/2 made the graph wide in comparison to the standard graph of x squared. Okay. The negative, though, reflected. So graphs of a to the x and graphs of -a to the x are reflections of each other. Across the x-axis. Positive coefficient above the x-axis, negative coefficient below the x-axis. Okay? So the absolute value of a is greater than 1. The parabola is narrower than if the absolute value is less than 1. That means that even if it's negative, doesn't matter if it's positive, 2, -2, they're both narrow, 1/2, -1/2, they're both wide. So some conclusions down here in this box in the bottom. If a is greater than 0, positive, then the parabola opens up. If a is less than 0, then the parabola opens down. Right? When we had a negative coefficient, it opened down. When we had our positive coefficients, they opened up. If the absolute value of a is a large number, then the parabola is narrow. Doesn't matter what sign it is, just matters what the number is, the value of the number. And if the absolute value of a is small, i.e. near 0, i.e. a fraction, then the parabola is wide. Those are our conclusions. Now we're going to look at some other modifiers. Okay. For example, the next modifier is going to be a k value added to the end of the x squared, the squared function. So I've graphed x squared plus 5, x squared plus 8. So I know that x squared has to be the light gray function because I know that 0, 0 is an ordered pair, 1, 1 is an ordered pair, 2, 4 is an ordered pair. So this outermost one is f of x equals x squared. Now, f of x plus 5, you take any of these ordered pairs and add 5 to them. 0 plus 5 is 5, 1 plus 1 is 6, or 1 plus 5 is 6, I mean. This would be 2, 4. If I add 5 to that, I would get 2, 9. So you can see that this middle one has to be the g of x function, the x squared plus 5. And similarly, you can see that this middle one, the innermost one, when I say middle, I mean this innermost graph, not the middle in between the graphs, but this innermost graph needs to be h of x equals the x squared plus 8 function because you've got 0 plus 8. That's the easiest spot to see it is you're adding 8 to 0, so 0 plus 8. Okay, so we've got each of those labeled. Explain how the k value affects the graph. It seems to be a vertical shift. Okay, just pushes the graph up vertically. And that's going to happen whether or not the k value is positive or the k value is negative. Here I've got x squared minus 4, and x squared minus 9. Once again, 0, 0 is an ordered pair of regular x squared. So f of x equals x squared is going to be the lightest color. Then the one in the middle has been shifted down 4. So that's going to be my g of x equals x squared minus 4, and the one on the outer edge shifted down 9. That's going to be my h of x equals x squared minus 9. So again, it's a vertical shift. To be more specific, here k was greater than 0, so that was up. And here k was less than 0, so that was down. Okay. So that summary is going to be, again, in the bottom of the box, the effect of k on the graph. X squared plus k being a positive value, the parabola is shifted up. K being less than 0, a negative value, the parabola is shifted down. Okay. Now, the y-coordinate of the vertex is k, right? Because the vertex, if the value is 0, is at 0 for the y value. If the value is at -4, the y value is at -4. So the k value directly correlates to the vertex, to the y-coordinate specifically of the vertex. Right. Now, next page, we're looking at the effect of h. H is a value that is added or subtracted to x. Now, keep in mind that h is the value after the subtraction. So h in x minus h is not a negative value. So here, if I see x squared or if I see x minus 2, 2 is the h value, 5 is the h value. Okay, so x squared, that one has had no shift to it, so it should have the ordered pair 0, 0 and 1, 1 on it. So this graph right here needs to be f of x equals x squared. Now, if I'm shifting 2 units from 0, 0, 1, 2, it's got to be this one, and this one, 1, 2, 3, 4, 5, that's got to be my shift to 5. So this one has to be g of x, which is a shift, this one's x minus 2 squared, and this one over here is h of x, which is x minus 5 parentheses squared. Okay. So these 2 units and 5 units were shifts to the right. Okay. So this is a horizontal shift. Okay. And here again, the h value is positive, and this is a shift to the right. It's a little bit more confusing in this case because it looks like the h value might be negative, but it's x minus h. The h value itself is a number after the subtraction. So the h value is 2. The h value here is 5. It's not negative 2 or negative 5. The minus is part of the formula, not part of the number in this case. So we have to always remember to use the opposite of the number that you see when you're inside of the parentheses with x. So instead of it being negative 2 for h, 2 is h. Okay, so that is a right shift. Conversely, if I have x squared, x plus 3 squared, x plus 6 squared, 0, 0 is always going to help me indicate the original function. And if I'm shifting 3 units, that one, 1, 2, 3, or 1, 2, 3, 4, 5, 6, these are going to be shifts to the left. So the 3 units, it has to be my g of x right here in the middle. G of x is x plus 3 squared, and h of x is x plus 6 quantity squared. Okay. So here, my h value is actually negative, right? Because x plus 3 is really x minus negative 3. And x plus 6 is really x minus negative 6. So the h value itself is actually negative 6. This is or negative 3. This is still a horizontal shift. But when you see a positive in there, the h value is actually less than 0, and so you're going to shift to the left. So if the h value is positive, the parabola is shifted to the right. And if the h value is negative, the parabola is shifted to the left. Don't forget, when you're looking for h is after the negative. If you see a positive, it really has to be a negative value from the double negative. And the x-coordinate of the vertex is h. Therefore, putting all pieces together, if you have an a value, an h value, and a k value, the vertex is going to be shifted in both directions here. H on x and k on y. X got shifted to h units, y got shifted to k units. So I can see, this is why this is called vertex form. This is the vertex form of the quadratic function because you can see the values of h and k. You can see the values for the vertex. Okay. Flip our page. Let's see what we have in the back. We got a couple of equations. I want to fill in the vertex, fill in whether the graph opens up or down, and how it is shifted. Okay, so in the first one, I can see the vertex. So I can see the h value and the k value. The h value here is 7. Remember, the negative does not come with the h value, so the vertex is at 7, comma. The k value keeps its negatives at 7, comma, negative 5. Does it open up or down? That's going to depend on whether the a value is positive or negative. It's positive, therefore it opens up. Is it shifted up or down? That depends on your k value. Your k value is negative, so it's going to be shifted down. Let me label what these are looking for. So this is my HK for the vertex. This is the question about A, whether it's greater than 0 or less than 0. Up or down is a question about K. Left or right is a question about H. And wide or narrow is back to a question about A. So just so we know which part of the equation we're looking for. Left or right, the H value is a 7, positive 7, so it's going to be to the right. And wide or narrow, so that's about A, and that is whether A is greater than 1 or between 0 and 1. This is a small value of a, so that's going to be wide. Okay. Once more, negative h value, right, because I've got a positive 1, it's a negative 1, so it's going to be a negative 1 for the h value and a negative 2 for the k value. Opposite of the number inside with x, always. Okay, so up or down, negative coefficient, so that's going to be down. That's the a value. Up or down, negative k value, so down. Left or right, opposite, so I'm going opposite of this positive one is negative 1, so I'm going to the left. Look at your vertex to see left or right. So you're going left. And wide or narrow. This 4 value is larger than 1, so narrow. Okay. Next, negative, negative. So that means my vertex is going to be at negative 4, comma. There's no number added to the end, so it must be comma 0. Up or down, positive coefficient, so up. Shifted up or down, this is going to be neither because you don't have a value for k, it's just 0. Left or right, the vertex is at negative 4, so that's left. Wide or narrow, 2 greater than 1, so narrow. Okay, last one. There is no number inside the parenthesis with x. That means that there is no left-right shift. So we have 0, comma. The number at the end is 6. That's my k value. So that means opens down or up. That negative coefficient is going to be down. Up or down. Up from the positive 6. Left or right, there's no number in there. So neither left or right. Wide or narrow, 1/4. Smaller than 1. So wide. Questions below. Which graph is narrowest? There are 2 possibilities for narrow. The narrowest has the largest coefficient. So if we look at 4, ignore the sign because it's the absolute value, right? So ignore the sign, so just 4 and 2. So 4 is bigger. So g of x is narrowest. Widest, smallest value. So look at 0.3 and 1/4. 1/4 is 0.25, so that one is going to be smaller. Again, you're ignoring the negative. That's just the up or down business. So now you're just looking at the coefficient. As its absolute value. So again, 1/4, 0.25 is a lower value than 0.3, so k of x is widest. Which graphs have 2 x-intercepts? Okay, I gotta think a little bit harder on this one. So it's going to be based on how they're oriented and how they're shifted. It's going to be based on these 2 columns. So the first one, let me just draw each of these over on the side right here. The first one opens up, but got shifted down. So and over, but it got shifted down. And the point is on that one, since it got shifted down, it is going to have 2 x-intercepts since it is opening up and shifted down. Okay, so 2 x-intercepts, certainly F. Okay, so G opens down and got shifted down. So it's like this. It has no x-intercepts. It opens down and was shifted down. Next, this one opens up but was not shifted up or down, so it's right on the x-axis. So it only has 1 intercept, so that's not going to have 2. Okay, and the last one, this one opens down and was shifted up. So again, it opens down but was shifted up, so it's going to have 2. So F and K both have 2 x-intercepts. All right, in example 3, we want to draw the graph of -3 times x plus 2 squared minus 4 by first placing the vertex in the middle and then finding equal points on either side and graphing it by hand. So vertex in the middle, I can see the vertex right here. It has to be at -2, -4. You can see the h and k values. Then I always just want to pick some consecutive points. So if I go smaller, that's going to be -3 and -4 for x, and larger, that's going to be -1 and 0 for x. I'm just going to plug those in by hand and find the y values. Okay. So let me plug in -3. -3 plus 2, that's -1. Squared is 1. 1 times -3 is -3. Minus 4 is -7. Okay. We plug in -4. -4 plus 2 is -2. Squared is 4. 4 times 3 is -12. And then -12 minus 4 is -16. Let me try the other ones as well. Okay, so I've got -1 plus 2, that's 1. 1 squared is still 1 times -3 is -3 plus 4 is -7. And the last one, I'm going to plug in 0. That's 0 plus 2 is 2. Squared is 4 times -3 is -12. Minus 4 is -16. You can use your calculator to help you get these y values. You should have the first one for free, basically, because you can see the h and k. After that, what you're just doing is picking consecutive x values and plugging them into the equation to find y. If you want to use your calculator to get those other 4 y values, that is fine. Okay? All right. State the domain. Well, the domain is a set of all x values that are possible, so it's definitely going to be all real numbers. So I'm going to write my interval for all real numbers here. The range, though. Okay, so the range, I need to know how this graph opens. I want to know up or down, and then I want to know what the vertex is. So this graph is going to open down, right? Because I see a negative coefficient, so it opens down like this, right? Because the -3. And since it opens down, the vertex is the highest value, which means that it's going to go all the way down to -infinity, but stop at that highest value. And the range is y values, right? So it means -4 is my highest value. So I'm going to have -infinity, -4. That was my range. And I do put a bracket around that -4 because I do actually achieve that value. So I want to make sure that I have a square bracket. So the range is going to really depend on whether your graph opens up or down and what the y value of the vertex is. The domain is always all real numbers. So let's graph our ordered pairs and see what a graph looks like here. So -4, -16, okay, -3, -7, and -2, -4. Then I've also got -1, -7, and 0, -16. Okay, so let's draw our graph. It looks like this. If I really wanted to, I could find the ordered pairs for 1 and -5 as well, just to flesh out a little bit more fully. But those are the ordered pairs I've got. And you can see your domain is going to be all real numbers, and you can see that your range is going to be from -infinity up until -4. Sometimes we like to graph it first just to see what the graph looks like before I write the range, but I would argue that we already knew it based on the coefficients A and the vertex. Okay. Let's look at the next page. All right, so the next page, we have several graphs right here where I just want to talk about the sign, like I'm just going to write positive or negative for each of these values. So this graph opens upward, which means the A value has to be positive. It has been, looking at just the vertex now, it has been shifted to the right, which means that the H value has to be positive. And it has been shifted up, which means that the K value has to be positive. Okay. So again, the H value is the left-right shift, the K value is the up-down shift. In part B, this graph opens up, so the A value has to be positive. It has not been shifted left or right. The vertex remains right in the center, so the H value is actually 0. It's not positive or negative. And the K value has to be positive because it was shifted up from the origin. Right, that up right there is my K value. Okay. The bottom two. This one opens down, so the A value needs to be negative. It has been shifted to the right, so the H value needs to be positive. And it has been shifted down, so the K value needs to be negative. And part D also opens down, so the A value is negative. This one has been shifted to the left, so the H value is negative. But it has not been shifted to up or down. The Y value is still right on the x-axis, so the K value is 0. So hopefully that gives you a little deeper understanding of the values A, H, and K and their effects on the graph. The last part, which graph has the largest absolute value of A? So the largest absolute value of A I would expect to be the narrowest graph. This is going to be graph D, explanation, it's the narrowest. And smallest absolute value of A, that's got to be part C. Look at all 4 of these because part C has the widest. Those are my explanations. I'm looking for a narrow graph for a large value of A, and I'm looking for a wide graph for a small value of A. Okay, and that's the end of part A.